In the name of God, my name is Mehdi Kortnavasi, and in this movie, I am talking about the Introduction to Database Management System, Chapter 2, Entity Relation or ER Models and Diagram. In this chapter, we looking forward a common language to define the problem definition and share this idea with all parties in the system development team, including the database administrator, developers, stakeholders, and we need to know how to communicate to all of these parties with a common language. We will use an ER diagram. Actually is mainly used for conceptual data modeling. The entity relationship models or ER is the communication between database designer and end users during the analysis phase of database development. This model is a representation of the structure and constraints of a database that is independent of the DBMSs and its associated data model that will be used to implement the database. And there are many DBMSs in the market, for example SQL Server or Oracle or Visual Files Pro or Microsoft Access in the Office. And in this model, the platform is independent from all of those. Database designers and practitioners introduce a new model named an Enhanced Entity Relationship Model or EER, which include the basic ER model concept with additional semantic concepts like specialization, generalization, and categorization. We will talk about this concept in the next slides. Let's start with some basic concepts. The first is enterprise. Enterprise refers to any kind of organization, any business sites. For example, a college, a school, bank, any company, and production factories, for example, a healthcare organization or education organization like a school, university. The next is entity. Entity refers to an object or thing in real world. Object may be any person, place, event, and account, anything in the database, in an organization. For example, a student of college and a school loans in a bank. For example, for designing to a database for a school enterprise, a student or a faculty or a professor or an employee or a course, all of those are example about the entity in a school. Or in a bank system, the loan or account holder or employee are the entities. The next is attributes or properties, or we will use instead field. These are characteristics of any entities. Each entity have a lot of attributes, depends on a data flow in the organization. For example, a student can be described by his name, age, address, height, class, and etc. Or a loan can be described by their types, such as house loan or car loan. Or an employee in any company can be described by their employee ID, name, department, or designation, or etc. A car as an entity can be described by his attributes like color, model, company, and etc. The next concept is the value. Value is the information or data which is stored in attributes of any entity. The entity set, or we will say as a table or a file, all the entities have same attributes make an entity set or a table. Domain. Domain or value set is the set of all values or information about any attributes, or a range of acceptable values for each field. For example, in here, enterprise is a college where students are studied, and entity refer to any single student with all his values in this example. For example, registration number, name, age, branch, semester, phone number. These are the attributes of the student. Here is an example of value. Let's 1A1 is the value for the field of registration number, or John is the value for the field of name, 20 a value for the field of age, computer value for branch, 1 semester, and here is the phone number. So these are the values. Entity set, all students are described by same set of attributes. So all these students combine together to make an entity set. We named it, for example, a student information or a student table. Each table includes many rows or line, and each line is for each student, and each column is an attribute or field. For example, domain for the field of name. These values are the domain for this name. Or for the age, these values are the domain. In this organization or in this enterprise, we cannot accept the age, for example, by -2 or age 159. So we can accept a specific range of values for this field, for example, and we say this is a domain or acceptable values. Let's see, here is a table or entity set. We named it as a student information, and this is an entity. Each row of this table or each record of this table is related to each entity, E1, E2, E3, and all of these entities have the same properties or same fields. Each column we say as a field, and the whole table we say as a file or table. The values and the domain. Type of attributes. There are simple or composite attributes. Simple attributes are those which cannot be divided into subparts. For example, age of a student. But composite type attributes are those which can be divided into subparts. For example, attribute of name of a student can be divided into three parts: first name, middle name, and last name. And we need to define three individual fields in a table to showing a name attribute, because name is a composite field. Or another type is a single value and multi-value attributes. Single, an attribute having only single value for a particular entity, for example, age of a student, and the multi-value, an attribute having more than one possible value for a particular entity. For example, phone number of a student. A student may have more than one phone number. But remember, we cannot save more than just one value in each cell of the table or in each field. So for implementation this concept, we need another table, and we will discuss about the multi-value fields with examples in this course. And derived attributes and stored attributes. Derived, an attribute that can be derived or derived from other known attributes. I call this as a calculated field. And for example, age of an employee can be derived if you know date of birth and system date. A stored field, an attribute which cannot be derived or calculated by other known attributes. For example, date of birth of an employee. Suppose if you have a field name by age in your table and you put 22, for example, as a employee age, what happened next year? And suppose you have 25,000 of students, you need to change all of this value next year, and you repeat this for the all future years. So instead of storing a fixed value for age, will define a date of birth instead in the table, and every time we need to retrieve or report the age of a student, we just calculate the difference of the system date and date of birth to get a value for age. So we say age is a drift value. The next is a null value. Null stands for nothing. An attribute have a null value if either the value of that attribute is not known or the value is not applicable. Null is not equal to 0 because 0 actually is a value in a numeric field, and null means nothing, no value in the field. The relationship set. Relationship is the association among several entities. There are many entities in each organization, in each enterprise, and for designing a database, we need to relate these entities together. And because of this, we say as a relational database or RDBMS. It connects different entities through a meaningful relation. Relationship set is a set of relationship of the same type. Consider an example. Employee work in different departments. So we have two type of entity. Employee as an entity and department is as another entity. The relationship exists between employees and department because each employee must belong to some department. Relation of all employees with department when combined makes the relationship set because each employee has same kind of relation with department. Let's see an example. Here, employee as an entity, E1, E2, E3, and department, D1, D2. And here is a relation. We named this relation as a works in, or any name you can assign to this relation. In this relation, employee E1 is belong to department D2, or E2 is belong to department D1. So this relation actually is a connection between each item of employee with the corresponding items in a department. We say as a binary relationship set because there are only two entities engaged in this relation. Degree of relationship set, total number of entity sets or tables participate in a relationship set is known as a degree of relationship set. We saw the binary relationship set in the last slide, because two entity sets are involved. And the ternary relationship set, a relationship set in which three entity sets are involved, and we say the degree is 3, the degree of relationship. Let's see another example. We add a third entity named job, and in this relation we relate three entities: employee, department, and job. We say ternary relationship set. For example, E1 is belongs to department D2, and his job is J1. And E2 belongs to department D1, and his job is also J2. In the real environment, we have more than 3 entities and in a relationship. So the number of or degree of relationship is unlimited. Depends on the situation. Mapping constraints. There are certain constraints in ER model. Data in a database must follow constraints, and they are act as a rules to which the content of database must conform. Every organization have its own rules. For example, in the university, there are many rules, and we say as a constraint to defining a database model. Mapping cardinality or cardinality ratio. It's the number of entities of an entity set that are associated with entities of another entity set through a relationship set. The first is a 1-to-1 or 1:1. An entity in X is associated with at most or maximum one entity in Y, and an entity in Y also is associated with at most or maximum one entity in X. Here is an example. For example, entity X is a country and entity Y is a president. Each country have only one president, and one president is only for a one country. We say the relation ratio is a 1-to-1. Relation cardinality is 1-to-1. The next is 1-to-n or 1-to-many. An entity in X associates with any number of entities in Y. Let's see an example. For example, X entity is a manager and Y entity is employee. So here a manager has many employees under it, but an employee works under only one manager. X1 manage employee Y1 and Y4, and X2 manage employee Y2 and Y3. But Y1 is managed by only one manager, X1. The next is a many to one or n to one. An entity in X is associated with at most or maximum one entity in Y. But an entity in Y is associated with any number of entities in X. Let's see another example, employee and project. An employee can work on a single project, while any project can be assigned to more than one employee. And the last type is a many to many or M to N. An X entity in X associates with any number, 0 included, of entity Y and vice versa, a student and subject. As another example, a student can have more than one subject, and one subject can be given to more than one student. The next concept is a key. A key is an attribute or a set of attributes that is used to identify data in entity set. The attributes which are used as a key are known as a key attributes. Rest of all are known as a non-key attributes. Actually, the key is a unique address, unique identifier to locate a single record to a table. And a super key is a set of collection of one or more than one attributes that can identify data uniquely. So a super key or key is a unique for each record. For example, assume a key for a car. Each car has its own unique key to start. Let's see another example here. The employee table have the registration number, ID, name, salary, and department ID. And the entity of department have another two fields, department ID and department name. So let's see an entity set has more than one super key. In this example, each employee have a unique register number. We can say as a super key. Also, each employee have a unique ID. So the ID is also a super key. In the another table, department ID is a super key and unique for each department. So for locating the record in a table, we need a key. And sometimes we can combine more than one field as a key. For example, here ID, name, salary, and register number we use 4 field, combination of 4 fields as a key to find the record. Or we can use ID, name, and registration number, 3 fields as a key. Or we can use only ID as a key because ID is unique. So the candidate key is another concept, the minimal super key. There are here 3 super key. We say the minimal super key is known as candidate key. Consider a super key and then take all of its proper subsets. If no one of the proper subsets are super key, then this super key is taken as a candidate key. For example, ID and register number both are a candidate key because each of these fields are unique. Primary key, important, very important, and we will use a lot of these concepts in the rest of this course. An attribute which identifies data uniquely is known as the primary key, or the term primary key is used to denote candidate key. A table can have more than one candidate key, but only one primary key. For example, here we can have 2 candidate key, register number and ID, but we will choose only one of these as a primary key. For example, ID. Alternate keys. All the candidate keys other than primary key are known as the alternate key. For example, if you take ID as the primary key, then register number is another alternate key, another unique address. And the secondary key, an attribute or set of attributes which doesn't identify data uniquely, but identify a group of data, is known as secondary key. For example, name, salary, and department number. Combination of 3 fields, name, salary, and department number, make another key, but it's not unique. Maybe unique or maybe not. We say as a secondary key. And foreign key. A foreign key is an attribute in any entity set which is also a primary key in any other entity set. For example, department ID, this is an attribute in entity set employee and also a primary key in entity set department. In this table, department ID is unique and is a primary key. We use same field in the another entity, in the table employee, we use department ID also, but this field is not unique in this table, and this field is unique in another table. So we say department ID here is a foreign key, and department ID here is a primary key. We will use to connect and relate both of these tables via the primary and foreign key. Okay, thank you for watching this movie, and we will continue in the next movie about of types of entity set and continuing to draw a diagram model. Thank you.